Geometry nodes in Blender are a very powerful tool that you can do lots of procedural and cool looking stuff with. And I just want to show you 5 setups today that you can use to make cool stuff that you can base your more complex setups on. And I'm going to show them and explain them. I'll try to make it beginner friendly, so let's start and I hope you like it. So for the first one, we're going to start with procedurally generating fractals. So for this one, we are going to start by adding in a cube and going to the Geometry Nodes tab and then creating a new setup. And what we will be using here is the repeat zone. So you can just search for repeat and create it, which is basically just gonna take a input, give us a output, and in between these nodes, in this orange zone here, it is going to repeat whatever is there once per iteration. So we can just feed our input, which is this cube, through there, like this. And also make sure to enable the Node Wrangler add-on, because we are going to use that. And inside of here, we are going to do a bunch of transform and join geometry operations, which will be repeated per loop, therefore creating this recursive fractal. I believe it's called a Sierpinski cube or something like that. So you're going to start off by creating a transform geometry node, putting that here, and moving the cube on the x-axis by 2. Just if you're wondering why I used 2 here, it is because the standard size of a cube in Blender is 2 by 2 by 2 meters. And then you can duplicate this. And if you hold Shift, Control, and then press D, it will keep this connection while duplicating, so you don't have to manually reconnect it every time. And then we're gonna create a join geometry node and join both of these together. And in this one, we're just going to set it to -2. So you have 2 cubes with exactly 1 cube of space in between. What we're going to do with this one is transform it also. So put a transform geometry here. Duplicate this with Shift D so we can join multiple things again. This one we're going to move by 2 on the y-axis. Duplicate with the connection still connected, join this, and this one should be moved by -2. So we have these edge cubes already. And then what you can do is collapse these by clicking this little arrow. So it's just a little bit less intimidating to look at, because these transform geometry nodes are very big and take up a lot of space, and it's very easy to get lost inside of your node setup. And then we can take this once more and just plug it in directly. So we fill the gaps in the middle, collapse all of these to make it a bit more readable. And then one last transform geometry nodes out of here, connect this into the join geometry and rotate on the z-axis. So we exactly have this kind of square shape with a hole in the middle. One thing that I'm going to do now is, because at the end of this we are going to scale the mesh, and it's always going to scale from the origin. So we want the origin to stay exactly in the middle of our cube. And if we were to build upward from here, so the next cube would be here, and then the third one would be here, the origin would be on the bottom of the mesh. So it would scale upwards and grow into the positive space of the z-axis, and we don't want that. We want it to grow equally in all directions. So we are going to create yet another join geometry and then transform this on the z-axis by 2. Duplicate it with the connection, connect it here, and this one is going to be moved down by -2. So now you can see the origin is exactly in the middle, and we just have to fill in these 4 corner cubes in the middle. And we already have them. Actually, they are right here, because we already created corner cubes for these 2 shapes. So you can just take them and directly connect them here. And we already have the most simple version of this fractal. But of course you will want to make some more iterations and make it a bit more complex. And you see, if I do this now, it just grows more and more into a bigger cube. And that is because these values by which we are transforming the mesh, which are 2 meters for now, are constant. But they would need to change over time because the mesh size is increasing. So what we can do is just scale the mesh down at the end of our node setup here by a factor of 1/3. So you just want to type 0.3 in here. The more threes you do, the more precise it will get. And what this basically does is keep the mesh the same size all the time, because every iteration we are increasing the size by a factor of 3, because in every axis we are stacking 3 cubes. And if at the end of it we scale it down by 1/3, it will stay the same size. So now if we increase the iterations, you can see we have a fractal. However, you can see at 4 iterations we are already at 1.9 million triangles, so I think 5 or maybe 6 is the maximum here, except if you have a really good graphics card, but you're gonna have to experiment with this. And one last optimization that we will do is utilize the merge by distance node, which is basically going to join all of the overlapping vertices that we have in here, because the cubes are put like exactly next to each other. So for every 2 cubes next to each other, we have 4 overlapping vertices. And this node just collapses these vertices into one, so we don't have any overlapping duplicates. And you can see if I put this here, our triangle count goes down from 1.9 to 1.3 million. Yeah, that's basically it. You can put any transform operations you want in there, and for example make this pyramid fractal that I showed you in the intro, or anything else you can think of. It's a very simple but cool setup that you can do lots of stuff with. For this one, I want to show you how you can make a mesh trail tool that makes a mesh leave a trail of itself behind, and also how you can use the skip function of simulation zones. For the next setup, I'm going to create 2 node groups or 2 different functions inside of the same geometry nodes modifier. So we're going to start off by creating a mesh. I'm going to use a cube, but you can use whatever you want. I'm going to go to frame 0 and create a keyframe by pressing I, and then move forward to frame 100, move it up a bit, scale it down on the z-axis, scale it up on the x and y axis, and rotate it a bit on the z-axis, and then insert another keyframe. Then I'm going to go down to the timeline, press A to select all of the keyframes, and then press T to set the interpolation to linear, so we have a constant speed all the time. And if I'm going to play that animation now, you can see the cube is moving up. Perfect. So now we need another mesh, which I'm also going to use a cube for. Go to geometry nodes and create a new setup. You can instantly delete this group input because we are not going to use it. We are going to use this cube that we have just animated. So just drag that into here, set the value here to relative, so we always have the current state of this cube, and set it to as instance. So we are using it as an instance and not as actual geometry. What you can also do is just hide this cube that we have just created, but only hide the object that has keyframes, that has animated, and not the object with the geometry nodes modifier on it. Now in our geometry nodes, we can create a simulation zone, which is basically the exact same as a repeat zone. However, it repeats everything that is inside every frame and not every chosen iteration. Connect this here, connect the geometry into here. And now everything that we do here will be repeated for every frame on this timeline. This skip button we will use later on. We can use it to purposefully skip certain frames that we don't want in our simulation. So what we are going to do in this simulation zone is first create a duplicate elements node, put this into here, and we have instances, so we don't want to duplicate points, we want to duplicate instances. And after that, we are going to join these duplicated instances with the current position of the mesh. So we create one copy each frame. Put this here. And if we play the animation now, you can see our mesh leaves a trail where every frame there's one instance added to this. You can use this for a lot of parametric design or making organic shapes or cool animations. You can put in whatever mesh you want, you just have to change it here. And yeah, it's a very powerful but simple setup that you can do lots of cool stuff with. However, maybe you don't want to actually simulate every frame and only want to simulate a certain selected frame range. And to do that, we can use the scene time node, which basically just outputs the current time in seconds and the current frame. So we just take the frame and we compare it. So now we compare the current frame to whatever value we set in here. I'm going to set this to less than, because this is going to be used to set our start frame. So I'm just going to set this to 20, for example. So basically that means I only want the simulation to start after frame 20 has passed. And then we can just take this result, which is a Boolean. So if this frame number is smaller than 20, it's going to output true. And if it is bigger, it's going to output false. And we can just put this into the skip of the simulation zone. So now it's going to skip every frame that is less than 20. Let's just test this. And you can see in the first 20 frames it does nothing, but after that it starts adding copies. And to put an end to the simulation, we can do the exact same thing. So just duplicate this, set this to greater than, set the frames to 80, for example. However, now we have two Boolean outputs here, but only one input here. And for that, we can use Boolean math nodes. Just type in Boolean math and set this to OR. Because if one of these conditions is fulfilled, we want the simulation to be skipped, or the current frame to be skipped. You can just put these right into there, like this. Drag this a bit to the side and connect this into the skip of the simulation zone. And now if we play, before frame 20 nothing happens, and at frame 80 the simulation stops. Perfect. One last thing I want to do is only simulate if our animated mesh is moving. Because if we add instances while it is not moving, they are just going to layer on top of each other and create a lot of unnecessary instances and shading artifacts. To do that, we just copy this object info. However, we have to turn off as instance so we can actually get the location. Then just take the location and put it into here. So what this does is every frame it stores the location of the cube, and then for the new simulation zone, for the next frame, it's going to output that previous location. So what we get here is the location from the last frame. So we can just call this previous location, and then this is the previous location, and whatever we get from here is the current location. To determine if the cube has moved, we are going to subtract these vectors from each other to basically get the vector that points from one to the other. So just take a vector math node, set it to subtract, and in the top slot we're going to put the previous location, and in the bottom slot the current location. You can collapse this and then create a other vector math node, which is set to length. It is just going to take in this vector and give us out the length of this vector as a float variable. So basically, if this float variable is 0, it means the current frame and the last frame are the same, so the cube has not moved. And if it is not 0, it means the cube has moved. So we can just compare this, set it to equal, and compare it to this b value, which we need to set to 0. And this result is going to output true if it hasn't moved and false if it has moved. So the same way we joined these, we can just duplicate this node and put it into here. So now it's going to skip every frame that is outside of our simulation range or where the cube did not move. To test this, you can just unhide your animated mesh, hide this one so we can see it better, and then move the first frame to like 30, for example. And if we play the animation, we can see it only starts playing at frame 30. Now we can bring this back. And to see how many instances you have, you can just drag open a new window here, set this to spreadsheet, and we can collapse this. In here we see how many instances we currently have. So now it's 57. And now let's go to frame 0 and play the animation. And now you see in these frames where the cube is not moving, it's not going to add any instances. Only when the cube starts moving and when our designated start frame is reached. You can basically use this Boolean setup for controlling the range of your simulations in any kind of scenario, so you don't just layer lots of geometry on each other or simulate in a time range where you don't want to do. For this one, I want to show you how you can make a base for a house generator, or better said, how you can procedurally generate beams controlled by user parameters. Okay, so now let's make the base for a kind of house generator geometry node setup. It really doesn't matter what mesh you use to start with this, because we are going to create everything in geometry nodes. So I'm just going to use a cube, go to geometry nodes, create a new setup. We can delete the cube, and we are going to start off with a grid. So just search grid. A grid is basically just a plane where you can adjust the size and the vertices. So just connect this into here, and there's our grid. Now you can see we have like 3 vertices on each side, but I only want 2. So we only have 4 vertices in total, 1 on each edge. That's exactly how we need it. And then what we're going to do to make it a bit more user-friendly and controllable is take a group input node and connect this gray socket to X and this one to Y. So now we can control these values outside of our geometry node setup in the side panel, and you can see we can adjust everything from here. Perfect. And what we want to do is create pillars or beams that make up the shape of the house. So for that, we are going to instance on these 4 vertices of this grid, instance on points. And as an instance, we are going to take a mesh line, set it to endpoints, which is basically going to give us 3 inputs. This one is going to control how many vertices we have along this mesh line, but we only need 2 for now. So 1 at the endpoint and 1 at the start point. And these are just 2 vectors in which we can tell the node from where to where this mesh line should go. So we are going to take 2 combine XYZ nodes, which basically just split this purple dot into 3 variables, 1 for each axis. Connect this here, duplicate it, connect it here. And now we can connect this mesh to the instance here. And you'll see we have nothing, and that is because the start and end location are the exact same. So for the end location, I'm gonna take another group input, which is, by the way, gonna give us the exact same values as here. You can duplicate it as many times as you want. And we're going to create a new input for the z-axis of the end location, which I'm going to call height. And if we increase this height value, you can see these lines start to grow. So now we already have the options to control both X and Y size and the height. And we're just gonna have to add the roof and the floor. But this is going to be very easy because we already have it here, because it basically is this grid. So just create a join geometry, join this into here. And while holding Shift and right click, you can create these reroutes, which are just gonna make it a bit more readable. So just create this here. Then another one that we are going to translate with a transform geometry. Put the result in here. Combine XYZ. So we can separately control the Z-axis of the translation. And we are just going to use this height value that we just created. So it will always be on top, no matter how we change it. But now we kind of only have these lines, which are two-dimensional, and you're not going to see them in your render. So we're going to have to solidify them in some way. And we are going to do that by turning this mesh into a curve. So just look for mesh to curve. Now they are all curves, and we want to instantly turn them back into a mesh with a node that's called curve to mesh. Put this here, but now you're not going to see anything because Blender doesn't know how to create a three-dimensional shape from these lines. We're going to have to tell it what shape it should use, and we're just going to use a curve circle, which just looks like this. It's just an ordinary circle, and then put it into the profile curve. They are way too big, so just decrease the radius until you have something you like. By the way, you can also take a group input and connect the radius into here, so you can also control that from this modifiers panel. But now they are completely round, and in these kind of houses, these beams are always shaped like a square. So we're gonna decrease the resolution to 4. And then also, so we don't have this weird smooth shading, just use a set shade smooth node and turn off shade smooth. And now you can see we have these kind of square shapes. However, they are rotated by 45 degrees. And we want this face and the bottom face to be like parallel to the floor. So we're going to have to rotate it by 45 degrees. So just create a transform geometry, put it here. And on the Z-axis for rotation, set the value to 45, which is going to rotate them in the correct way. Okay, perfect. Now the last thing I want to do is basically create a roof for this house. So we have a line that goes in the middle like this, and it's just somewhere up here and then connects in a triangle shape to the house. So for that, we are going to, first of all, take all of this and move it to the side a bit, and then another mesh line. Set this to endpoints, so we can set the start and end location, set the count down to 2, and connect it right here. So now it's just going to be like vertically standing there, but that's not what we want. So just take another group input, and we're going to take the x-axis and put it into a combine xyz. Oops. So we can change only the x-axis on this, or better said, change all of the individual values. Put this into the start location. And now you can see it's going a little bit too far. And that is because the x-axis value that we have here gives us the exact length from this point to this point. But for now, we only want it to be from here to here, because the line starts in the middle and not at the edge here. So we're just going to have to divide this value by 2. So math node, divide, set it to 2. And now you can see it is exactly on the x-axis. And for the end location, we are just going to do the same thing. So plug this into here. Now it's going in the false direction. You're also going to divide it by 2, but then we'll have to multiply it because this will go into the negative direction of the x-axis. So just multiply it by -1, which will give us a line that is always perfectly aligned from one side to the other. So now let's move this line up so we actually have it where a roof would be and not in the floor. I'm just going to collapse all of these nodes to make it a little bit more readable, except for these ones because we still need them. So move them down, and we're going to create a new input. Just put this into the z-axis for both of these combined xyz values. And this is going to be called roof height. And if we increase this, you can see we move this thing up, and this looks about right, where a roof would be. And now the last thing we need to do is create these diagonal lines that go from here down to the edges of our house. So just collapse this, take this, and we can just name these nodes. So it will be a little bit more understandable. Just select all of them you want to group, press Shift P, and then you get this box. And now you can just select the box, press F2, call this main beams, and this is going to be called curve to mesh, because all this just creates this square shaped mesh from our curves. So now here, just add a join geometry so we can join some other lines into this. And we are gonna again start with a mesh line. You can just duplicate this, keep everything as it is, take a combine XYZ. So it should start here and end here. So let's start with the start location. So let's connect this vector into the start location, take a group input, and the Z location is gonna be the roof height, because this is where it should start. And the X location should be the size on the X-axis divided by 2. Math node and divided by 2. Okay, perfect. So we can already see it is exactly where we want it. But for the end location, we are going to have to move it a bit. So duplicate this. Now for the first time, we're going to take the y-axis, put it into the y. However, we are going to do the exact same thing. Of course, connect this to the end location. Divide it by 2. You can just duplicate this, put it here, and it's already in the perfect spot. So now we just need to move it up to the height of the top of our cube. We can just use the height input that we created and put it into the z-axis. Perfect. And then we will need to move it on the x-axis to this edge. So you can just take the x-axis divided by 2 that we already have here and put this into the x-axis. All right, perfect. Now just take all of this. You can select all of these nodes and then press Shift G to create a node group, which is basically just going to give you this custom node that makes your node setups a bit more readable, because it collapses a lot of stuff into just one node with all of these custom inputs. And we are going to take our geometry up here and create a transform geometry, put this into geometry, join it into here, and scale it on the x-axis by -1. So we kind of mirror it to the other side, and then we'll just need one more duplicate of this. Actually, let me just put both of these into a join geometry, so we have these two beams separated, and then we can just transform them again, but this time scale them on the y-axis by -1. Connect this here, and there we are. So now we kind of have this roof that we can control the height of, and if we change the height here, it is also going to adjust. Now let's just take all of this that we've done here and put a frame around it, call it roof. So now you're just going to be able to have your setup a bit more organized and actually see what you're doing. And that's basically it. A very simple setup. We now have this kind of house that we can control from here. Of course, this is very simple, but you can add way more beams. You could add doors with this technique, or support beams, or really anything you can think of, and make some really powerful generators with it, where the user will just have to adjust these variables to change the shape. And for the last one, I want to show you how you can make a solid base for a landscape generation tool. Okay, so for this one we are going to make something like a base for a procedural landscape generation tool, or better said, terrain generation tool. This time we are going to start off with a plane, because the generated landscape is going to be based on user-generated geometry. So just switch to the Geometry Nodes tab, close this window and create a new setup. And the first thing that I want to do is subdivide this, so we have more geometry to work with. So just take a subdivision surface, put it here, and you can expose the level so that you can set it from here. For the beginning, I'm going to set this to, I think 5 is good. And then what you're gonna do is set this to keep corners, boundaries to none, and for the edge crease number or value, I found 0.33 to be the best value. And what we're going to do with this geometry is displace it. So the first thing that you will need to displace geometry inside of Geometry Nodes is a set position node, which will enable you to make a selection. So here you can select what geometry you want to displace, and then either offset every point's position or give every point an entirely new position. So if I offset this here, you can see everything moves up and down because I'm changing the values on the z-axis. And what I want to do here is blend between rock walls and grass. And every face that is kind of flat should be grass, and all of the walls that go vertical should be rocks. So the way I'm going to do this is use the dot product. So let's just take a normal node, which just gives us the normal for every point in here. And then from that normal, you can take a vector math and set it to dot product. Yes, here it is. So what this does basically is compare these two vectors that come into here. And it gives out a value between 1 and 0. This value that we get out of here tells us about the angle between both of these vectors. If this value is 0, it means that these two vectors are perfectly orthogonal to each other. And if it is 1, it means that both of these vectors are pointing in exactly the same direction. So what we will do now is set this value to 1. So we have a vector that points exactly upward on the z-axis. And now we can look if these faces point in the same direction or if they point to the side. And based on that, we can blend between grass and rocks, because grass should be the flat faces, which have a normal vector that points up, and the rocks should be the vertical faces, which have a normal vector that points to the side. So we are going to use this value to mix between two vectors for displacement. So I'm just going to take a mix node and set that to vector and use this value as the vector, and the result can go into the offset of the set position node. Now we need to create two different displacements, one for grass and one for rocks. I'm going to start off with the displacement for the rocks. So I'm just going to begin by adding a noise texture to keep it procedural. And you can just copy my values, but I found these to work the best. So for the scale, I'm going to use 0.3. For the detail, I'm going to use 6. The roughness can go up to 1. And this value, which I can pronounce, and the distortion can stay at their default value. This value that the noise texture gives us out here goes from 0 to 1. So it's going to displace into the positive space. So like here you can see Z, X and Y, and it's only going to project in this direction and not to the negative space, because the value goes from 0 to 1. To fix that issue, we can just take a vector math node, connect this into here, and then subtract 0.5 from this. What this does is now give us an average output of 0 and not 0.5, because if we subtract 0.5 from this range 1 to 0, it gives us out a range from minus 0.5 to 0.5. Now we just need to multiply this, set it to multiply with the normal, because we want to displace along the normals. So just put this into here, and then after all of that, just another vector math set to scale, so we can decide how strong the displacement should be. And this is gonna go into the top slot of this mix node. Let's just take some geometry so we can see what we're doing. I'm just going to extrude this edge upward, and you can instantly see the vertical face is getting displaced and the flat face is not getting displaced, and we're getting a nice blend between these two faces. And if you increase the subdivision level, the detail is gonna get even better, but it's gonna create a lot of geometry, so I'm not going to make it too high so everything runs smoothly. I'm just gonna put a set shade smooth node here, so it looks a bit better. Perfect. And now let's make the grass displacement, which is going to look very similar. You can just copy these down. Let's just press Shift P to put them in a frame. Call this grass displacement. And the top one can be rock displacement. For the grass displacement, we're just going to change the values of the noise texture. So set the scale to 1, the detail to 2, the roughness can go back to 0.5, and the other two values stay the same. And now just plug this into the bottom slot of the mix node, and you can see we're getting now a very soft displacement for the grass. I think we can even turn down the scale of this to maybe 0.3. Yeah, that looks about right. And you can already see if we start to create new geometry now, it's going to adapt to the shape, and it's already working pretty good and looking very cool. However, I want to do some more things with this. The first one, because on a grass field like this, you're gonna have small plants or rocks or maybe even trees scattered. So we can use this very mask that we made here to also scatter stuff on the grass and not on the rocks. To do that, just take a join geometry node, because we're going to create particles which need to be joined back to this mesh. Put it here. Take a distribute points on faces node, plug the points into here. As geometry, we are going to use this. So now it's giving us these points, but we don't want the particles to be scattered on the rocks. So we're just going to take this dot product value and compare it. And you can set this to equal and plug the result into here. Now we're gonna have to increase the epsilon. Now you can see it's exactly the wrong way. So just change this b value to 1. Now you can play with the epsilon, kind of a threshold. And now you can see we are only getting particles on the grass, which you could use to, for example, use a instances on points node, put that here. For now, we're just going to use an icosphere as a rock. So type in icosphere, put it as an instance, scale it down, and you have rocks or bushes or whatever. You could also put a collection of different plants and assets here to scatter them. It's really up to you how you want to do it. And for the geometry nodes part, this is pretty much it. However, a landscape looks boring just with this solid gray texture, and it would be cool if we could assign materials based on the terrain type that we are generating. And I'm going to show you how to do that. So first, create a material, and I'm just going to name this landscape matte. Then we can use a set material node here and set this to landscape matte. To now work on this, switch to the shader editor, and I'm just going to go into material preview here, and now we can start working on this. So here I have two shaders that I have from BlenderKit, and we are going to use them to blend, and we're going to use them for the landscape. This one's a rock shader and this one's a grass shader. So you can delete the principled BSDF and take a mix shader node. Just plug this into the surface and the rock into the top slot. You can use whatever rock material you want. You can just get a free PBR material from wherever you want. And the grass into the bottom slot. Alright, now we're just using 0.5 as a mix factor. So if we just wait for this to compile, yes, you can see we have a mix between both of these textures, but that's not what we want. So we need a similar mask for this factor that we had in geometry nodes. And for that, we can just use the geometry nodes, which gives us information about the normal. So just take this, again, take the dot product, set the z-axis to 1, so we have a up pointing vector. And then we can already use this as a factor. Alright, and you see it worked. To get a bit more control of how it looks, you can just take a color ramp, put it in between the factor and the dot product, and start tweaking it to, you see, it's kind of a threshold setting. I think something like this looks good. So now we're getting this rock material here and grass here. And yeah, that's pretty much it. We now have a very solid base for a procedural landscape generation tool, which you can do, again, lots of cool stuff with. Just play around with it, change the settings to your likings. And one more tip, you can also get some textures that have displacement maps. This grass material unfortunately doesn't have any, and then mix these displacement maps the same way we mix shader, plug them into here, and you're gonna also have dynamic displacement. That's it. I hope you liked it, and I'm looking forward to making more stuff in the future.